Good evening, everybody. Welcome to TWED. Just a couple logistical reminders. There's our sign-up book. Please sign your name. It's not attendance. It's just for the bean counters, so they know who ate the pizza. Just a schedule note. We do not have a TWED talk next week. The following week, we have a TWED talk on the submissions for website 2013 with Gazuka. So we have a number of talks. Another note is that this talk is being recorded and it's being streamed live out to the interweb. Please take note of that when you ask questions. And without further ado, that's Amar. Vishwanathan? Did I say it right? Vishwanathan?
Vishwanathan, yeah. Amar is fine.
And so a little bit of a partial apology. When Amar originally volunteered to do this talk, he offered to do sort of a tour of jQuery and Sparkle and a sort of a re-engineering of some of our Tedlos World demos, kind of demonstrating the capability. But he's been focusing on this, on F#, and he'll tell us a little bit, give us some context for F#. And he's pretty excited to be able to discuss that. So he's going to focus on that today, and it's going to be interactive. Are you going to talk about jQuery at all, or is just going to focus on F#? That's fine.
Focus on F#, probably if I finish it very early.
That's okay. So a little bit of context for this. F#, and I'm sure he'll repeat it and correct anything wrong. F# was created it's a functional programming language. It was created about 3 years ago at Microsoft Research in Cambridge by Simon Peyton Jones. And it recently, a live interactive programming portal called Try F# was created. And our friends at Microsoft Research have been encouraging us to play with it. And so Amar has been playing with it. So this is I hope some of our friends at Microsoft are watching this. Without further ado, take it away.
Okay. All right, everybody. Thanks, John, for the introduction. I've just been working around probably 3 or 4 weeks with F#. So yeah, without further ado, I'm going to tell you what's more exciting about this and what made me choose to do a TWED talk on F# instead of jQuery and all that. So yeah, the outline, what's F#? I'll still be going on to a brief introduction to functional programming, just 2 or 3 slides on what functional programming is about, and that will give you an idea of how to program in F#. An introduction to functional programming, or if you have experience with functional programming, helps you acclimatize to F# much more easily than if you've been working only with the other programming languages like Python or Java or C, C++. Advantages of F#, and then something much more interesting with Microsoft is that we can try F# in our browser, and you would see that it's very simple, and you could try this in your browser instead of having a Visual Studio development environment. And what you could do in tryfshop.org is pretty much powerful, that Microsoft allows access to different data sets, and also allows us to create our own type providers, which I'll be talking about in much detail, to these data sets and so on and so forth. And a bit about F# for the semantic web, on which I'll be working this semester with Eric, and future work. That's just redundant there. So what is F#? Like John said, John gave you the history. Probably this is more the technical definition for F#. Functional programming language from Microsoft, strongly typed or statically typed, open source. That's why it's in bold. Open source, cross-platform. Again, functional first. So one of the advantages of F# is that it reduces time to deployment for applications, and you would see why it reduces your time, because you just have to type it in and start compiling. Iterative development is possible in F#. So uniqueness. Okay, as a programmer, not as a researcher first, probably because I'm still in my second year of PhD, I'd call myself a programmer yet. Lesser code, more often than not, when you write, when you want to do complex things in programming languages, if you're a reasonably good programmer, you tend to write a lot of things. You tend to call a lot of libraries. You tend to interact with more than one system. So essentially, when you try accessing data, you need to know SQL. You need to connect to these data. For example, you need to connect to a SQL database, get data from, use my connection providers for different languages, learn how to write connection providers, and then work with them. You'd see that's not required in F# as you go on. That's one thing which made me, sit up and take notice at F#. Interoperability, obviously most languages provide these, but F# it's much more intuitive, much more easier to access inherent functionalities. In this case, with C#, and the other one is information rich programming. So, like I told you, accessing data is always cumbersome, sometimes cumbersome for new programmers to different programming. I mean, when you start working with data, it's much more difficult, but F# slightly easier if you get to know what it is. And so what are functional programming languages? Functional programming languages, example scheme, Haskell, some of you would have worked with it, but the basic concepts of functional programming languages are that functions, you could use functions as values to other functions. You could use functions as, you could pass functions as parameters instead of, I think I can give you an example here. So here's an example of a functional programming language scheme. So you see the definition of a function there. The definition of a function works with read, evaluate, print, and loop. So it's more like this is an expression. Evaluate this expression. Again, that turns into an expression. You print that expression and then keep continuing with it. And so it's more like how you would visualize recursion. And these are the examples. 1 plus 2 would probably be the operator first and the arguments later, and so on. And if you want to define a function, it's going to be function name first, arguments later, body later, and then. So this is your equivalent to. This is a C function, and equivalent is the scheme equivalent is given on the left side. So this is how a simple functional programming language works. It's called the REPL scheme. We'll just move on to working with F#. So, as always, we start a programming language with printf hello world. So probably I just thought I could include that. Printf and hello world is much more easier. We could try that and try F# later on. So these are certain concepts of F# or even any functional programming language, but more so in F# that we look at. The first one is bindings. So we use this keyword called let to bind values to functions or expressions. You wouldn't call this a variable, you would rather call it an expression or an S expression in functional terms, but you bind that value to this given expression. Now the other thing is that this value cannot be changed to, essentially these expressions are immutable. You cannot change their values, and this was again writing a simple function in F#. This is just an addition function. You see that let you name an expression called add, give it arguments, and also give it the operation which is what you want to do, x plus y. And one other interesting thing that you look here is that in any other programming language you would have talked about the types for x and y, which could be integer, float, a string, or anything of that sort, but we don't do that in F#. F sharp infers type by itself, and that's one of the major advantages of using F sharp is that it infers your types by looking at the operations. The other thing that I was talking about is functions as values. Now this is something which we don't see in our programming languages, but which is much more frequent in Scheme or Haskell. F sharp also provides that. We see that this is a very simple function. Could anybody, just looking at the definition, tell me what this is? I mean, definitely Eric knows more about it, so I'm not going to ask him. Anybody else, do you look at it and seem to make any... There's a reason why I didn't give comments, because I just thought if I just gave you 3 or 4 lines of F sharp code, just want to see how much of it is easily understandable. And this is key to the central concept here is that you are assigning a function as a value. You wouldn't be doing that in a normal programming language, because you wouldn't be normal programming languages don't allow us to use the same function, the value of a function. But here it's pretty simple. I'm just creating something known as increment 2, x plus plus and x plus plus again. So to do that, I'm just creating another function called increment, and using that in the same function definition to create an increment 2. So what I'm using in increment 2 is that I'm using a function called increment twice. I'm just passing the value of a function to another function, and this is, we'd probably look at it in much more detail. I'm just going through this, and we could try it out in the F sharp environment rather than Visual Studio, which is also something which we want to talk about. And then there's something else called higher order functions. So higher order functions are this here, you're using one function to call another function. Higher order functions is essentially like how you would work with think of a mathematical expression of calling 2 functions, of f of g of x, probably something like that. That's the equivalent what's happening here. I just create something called as an isSample. IsSample takes in x, it looks for the value of x. If x is got a value called sample, it's going to print success, or otherwise it's going to print fail. There's another function called a value test. It's going to give sample to test, and then that's what I do here. So I call value test. Value test would pass the value of sample to test, and then that goes to a sample. That's how this works. This would this would just print success. Another key data structure. Obviously, any programming language would have data structures. F sharp provides us something called as list. List, and that's a simple definition of a list, wherein you create a list of values which have 0 to 100, and obviously you use let as the binding first 100 to the value. You also have, these are inbuilt functions. List.map is an inbuilt function. List.filter is an inbuilt function. All these, you don't really have to know all these. The development environment easily gives us and so this would be the traditional definition of combining 2 functions, but F sharp provides us another operator called the pipe operator. So in this case, one thing to be noticed in the pipe operator is that the order of evaluation, you can use the pipe operator, the order of evaluation. So in this example, list.filter would be the first to be evaluated, and then list.map. So that's what we do here. I think if the pipe operator makes, this is much more confusing for people who are not very familiar to functional programming, but the pipe operator makes that much more simple. The order of essentially you chain functions in the order in which they appear. Another example is just how you create a simple list and then filter map. So map is basically filter x mod 2 equal to 0 essentially. All is bad. That's a bad example. I'm sorry. So let's say that was x greater than 2. You're mapping the map function takes in each of these arguments, multiplies it into 2, and then the third function is basically the sum. It sums up all the elements, all the values of the elements, which should be I think we could try that. And so I just wanted to, the only reason why I was rushing through with my PPT is to show what try F# is all about. Whatever information is there is much more easier to try and work out here. And this seems to be very exciting because you really don't need to have Visual Studio. Obviously, there are it works on the Silverlight platform. So any one of you having Linux, it's not going to be easy to work with try F#. So people having a Mac and a Windows machine could easily work on it. Other than that, try F#.org. So that's probably and Microsoft allows us to create our own profiles and upload code and work with code, work with everything there. So probably we just I'll talk.
So does this only work in IE or does this work in?
No, I'm actually using Chrome. I think that's more of a force of habit rather. I haven't actually.
Well, that's a good thing. But only in Chrome under Windows? Okay.
Yes, Chrome under Windows. So it's Microsoft. Even though it's open source, you still have to do something. Probably if you had Linux, get a virtual box, install Windows, and I haven't actually.
Yeah, that's what I'm going to do.
Yeah, that's the only way. Apart from that, it still has a lot of cool features that we want to check. Essentially, one major feature which is called as type providers makes accessing data easier. That's what we're going to talk about. Before that, probably just a quick running of all the examples that we looked at.
Yeah.
I know I've been fast. How many of you are still able to figure out what's happening? Okay, so 1, 2. Okay. Okay, what happens here is that a list is created with 100 entries. 0 to 100 are the values filled in the list. We create the chain, the pipe operator. Now, list is a type provided in F#. I've not worked with .NET, but I assume list is an inherent type even in .NET. So what happens is that F# obviously, like any other IDE, provides you all the functions that you would want to work with. And what happens in the first step is that.
So I think this is what you're about to show is a pretty important thing for why you're doing this in the first place.
Yeah.
So I think I think you need to be pretty, just continue on, but be very clear about this, you know, the role of the type provider in sort of advising the pop-up type of stuff. I think
Yes.
you have to
So
be very careful.
So in this case, one other thing, list. This is something which you would see in any IDE, probably Eclipse or even .NET or any of these IDEs will provide you. List has a set of functions, properties, methods, all those things, and then control space would give you the entire list. But I think type providers. I would go to type providers. Before that, I just say that there's one more style of definition there, list.filter. It takes in a function, which is a filter function, and I say that anything, probably any element greater than 50. So I filter the list to any element greater than 50. So that I probably have another 50 elements. I multiply each of those 50 elements by the second function, which is mapping, and then multiply each of those elements into 2, and then I have a list of 50 elements, and then I sum that entire list, which is the answer that's given here. So you could. This is a very good. This is basically called as chaining of functions. You would even see that in other. You could also see the same thing in jQuery, which is chaining of different functions. You could probably add one more average.
Well, yeah, sum is returning an int or a double or what?
Oh, yeah.
In this case, right?
Something which is much more simpler. Interesting, that works. Oh. I'm sorry, what happened? Okay. So this is how you use the function chaining, and the function chaining using the pipe operator. I was also talking about values being immutable. So let's say let a equal to a value equal to 5, and we never specify the type for a value, and you would see that my F# actually gives you the infer type, which is here int 5, and then you could see that let's say you say that goes string, and just to float. So this is what I was talking about, inferring types, and you'd see that this is an important thing when we go on, and where it makes things easier for us, particularly with what we work, the way we work with data. So one other thing, that normal programming languages, you could easily say a value is 7, and this is this is just to show you the property of immutability of each of these values. So you can't just change the values of the bindings that you have. So that's just not possible, and F# wouldn't allow you to do that. So some other little things which F# also allows us to define data types of our own kind, just like how you would do it in an object-oriented programming language. Probably the equivalent would be create class, book, and then float name, float author name, string name, string author name, int rating, and so on. This is the equivalent in an F#, and then what you do is you could just create values, and querying those values would be where the thing.
Is it white space sensitive like Python is? Because you've got that
Yes,
indented before. So you're trying to reference watchman in its own definition, right? Or does it know that the ending curly brace there ends a block and you can't continue any further?
It is white space sensitive, just like how Python is, so it relies on indentation.
Right, so my point was
Mhm.
that you were indented by 4 characters, so it might have been confused by the fact that you were referencing watchman inside of the watchman definition. When you were trying to type online before.
I don't think so. It's more got to do with my.
What's the issue?
Let me see. It's more to do with F#, I guess.
What's the issue? It's not pulling up the.
It's just not pulling up the. You see? Stop. Yeah. Okay.
So it's just what you already had in the workspace is causing problems.
Mhm. Okay. So I'm just.
So it might help a little bit, so we can see inside your head. Talk a little bit through when you're doing this, when you're demoing. Just talk us through what you're trying to do while you're doing it, so that we can follow along a little bit.
So what I'm trying to do right now is to show how inherently type providers work. In this case, it's just a very, very rudimentary explanation of how a type provider would work. In this case, the data is right in front of you.
Right.
And so suppose you wanted to access that data, how would you do that? Let's say you didn't, the idea is to show how type providers at a very basic level work, and then move on to show you where you really don't know what type you're talking about and still could access data about a type. So in this case, I'm just creating something known as a book, which is pretty simple, and then creating Watchmen.
So you're expecting to type in book dot and see a list of
Mhm.
the properties, I guess. Members.
Smelly one on the head.
Okay, so this wouldn't seem very cool right now, because any IDE would provide you this kind of an interface to work with, because I'm sure all these IDEs work, but hold on with me. We go to much more complex examples wherein you start understanding why this operation was important, or I showed you this operation. Okay, so that's about types, and then, okay. Did I miss anything? All right, so. Just assume that book is a type, and then there's another problem with try-f# which I'd like to tell you all. Suppose you wanted to access data, or the examples that I'm showing you, you'd have to go to the right link which they've given here. Or you couldn't just so each of these links getting started with each of these links has a special purpose, so that's something which Microsoft should work at, getting it right, because any of these interfaces should easily work. Okay, I just directly get into data analytics and then probably interesting. I think now I realize why I should use IE.
What's the issue?
Just say you need to do this in IE?
I'm just unable to click on one of the. This should be fine. So. Just a minute. Seems to be slow.
On this network?
Okay. I think probably we should just use the previous example there and start working with that. This is So what I'm trying to show here right now is you have data in different formats. So F# allows you to access this data without having inherent knowledge about the data. Two ways to look at it. One, let's say when we start programming, we teach us all the cool stuff of working with databases when we probably in our undergrad. What happens is that we realize that to access these databases, we need to know SQL to access these databases and query, and we also need to know how the database schema looks like in order to retrieve values from that database. On the other hand, suppose you wanted to use those values on a web application, you had to integrate your web application with SQL and then retrieve those data. Now F# on the other hand has something called as type providers. What type providers are basically is that you create a script probably. You create a script somewhere which tells you what kind of data you're looking at, and this script is loaded somewhere else. Anybody who imports that script can start working with data. And one such example, let's good. I think I figured out that work.
What's
It's
is it not loading examples?
It's just not loading an example data set because they have a pretty decent example here, and after that okay. I haven't you explained. This is one easy example of F#, which they have it in their own website. And one thing to know here is that they provide something known as a type provider, which allows you to access data of different kinds. So you would have type providers for SQL data, you would have type providers for CSV, you would have type providers for hopefully RDF, type providers for RSS feeds and different kinds. So in this case, we are looking at a data set, which is a DataGov data set, and it's in a CSV format. We are we are actually calling the DLL here allows us to use the CSV type provider, and then we look at what this data set has, using this line. Think of this line as probably the open connection in any of your Java pages to an SQL database. This is what this is the equivalent to that, and now
but it's not opening a data connection. You're defining a type on that line, as far as I can tell, based on that keyword.
Oh, sorry.
And then you're creating a new instance of that type on the on line 6, right?
You create a type called as type info,
Right.
which actually loads in the entire data of the CSV file. Now, let's say instead of this you had a database.
Oh,
Let's say you had a database. You could just create a type, which would take in all the values from the database, and you wouldn't need to use.
Why does
MSP.
it have to do it when I create the type? Because that seems like it would be excessive for just defining something.
A probably much more easier example would be here.
Couldn't you lazily do it when I actually instantiate an object of the type the first time, rather than having to do it when I define the type at the beginning? Or is that due to the fact that it has to be statically checked?
It has to be. That's due to the fact it has to be statically checked.
Okay.
So if the data type on the other side changes, you'd have to recompile the program again. What happens is that you actually compile a type provider which you are importing here.
Alright, so compile time reads the file in and generates a type for me. Then
Mhm.
what happens if I send you my exe and in the meantime the file is potentially changed again, right? You can't just recompile unless I send you the source code.
You'll have to do it again here. You'll have to. That's how it works. So, for existing data sets, if you could create a type provider for existing data sets, accessing data from those sets is much more easier.
Alright, I'm just thinking of a situation where someone decides they need to add a new attribute to a CSV file, and then all of a sudden, all my existing code that ever read that CSV file
I
was
had I had the same question too. We're looking at it, but
well, I don't think it's just a question. I think it's an extremely valid concern.
no. That's one of the things that F# is looking at, are constantly changing data schema, rather. In this case, let's say the data in the CSV file changes, but the format is still the same. You still be able to access it. But let's say you add an extra row or extra column, then probably you'll have to write a type provider again saying, okay, you have added an extra column and then you need to access those values. That's how it works here, because the only reason is because it's a statically typed, like you said. You need to know the type before you work on with it. Simpler example would be to work with
Visual Studio or pop-up videos, browser videos.
Oh, it's just because the Windows not maximized. It looks very fun.
What are we trying to do here?
Okay, so what I'm trying to show is the relative ease in which you could access the data. And one such example, probably this is a much better example. This type provider does not work on the try-F#. Try-F# only works with the given type providers that they have there, like the World Bank data gov sets. But here I'm actually using the OData, and Netflix has an OData interface, so I'm just using the OData service that Netflix provides us here.
So OData is the Microsoft Azure Open Data Protocol. Right?
Yeah. And so I'm just creating a type called a Netflix catalog, getting the entire Netflix catalog. Now what happens now is interesting. So in normal programming languages, in other, unless you know the structure of data, you wouldn't be able to check. But here, data context, so you'd get all the data that you have. Titles are probably, let's say, does anybody get what's happening here?
Can you
So,
extend the data context with custom?
so these are, so the
These
answer,
are the ones which
we gotta answer your question first. Okay, and what you're demonstrating is these are the columns
Yep.
from that data set.
From the data set.
Right, now was that pulled down live, or this is part of the definition of the provider?
This is pulled on live now.
Okay, so it's seeing those columns,
Mhm.
and it's, so if you went and added, if Netflix added a column, or where's this data set posted? This is live?
This is live at, yeah.
At that.
Mhm.
So if you went out and added a column, it's going to add that column in this, in what we're seeing? Or is this set of columns hard-coded into the provider definition? Where is it getting that from? Is it pulling down that set of columns?
Pulling it from the OData.
It's pulling out from.
It is from the,
From the OData. So if you added another
Okay.
feature to the OData service, then that
It's going to be.
so OData is, that service definition has this in it?
yes.
Yep.
Okay. So if you wanted to extend, if you wanted to add another column, you'd add another column to the data, the
To the
database,
data.
you'd modify the OData interface to show that, and then this would show up.
This would show up.
Okay, so it's sort of live.
But what happens is live, and that probably is the most cool thing about F# is that you could do this live, and accessing data is much more easier in this case. So it's just 4 or 5 lines of code, and working with data is much more easier. So,
But this is an OData thing.
mhm.
So this is Visual Studio talking with OData on the
with
far end.
OData. Yep.
Um,
Now this could not just be OData. This is an example of a type provider that F# provides for you. It could not just be OData, it could be SQL,
Yeah.
it could be, it doesn't have RDF yet, but
Well, that's the question.
it does not have RDF yet, but accessing Hadoop, Freebase, there is an example for Freebase or try F#. But so as long as a type provider exists for accessing data, you could use it with F#, and F# allows you to write your own type providers, which is what makes it cool.
So so I guess this is segue. What would a type provider for RDF look like? I mean, does the question even make sense?
If I knew that answer, probably I'd be right now giving a demo to Professor Hendler. So a type provider so RDF, from what I can think about RDF, it's massively linked data, and to get those types live does need some amount of cheeky programming on it, and that's what we're trying to do here. Now in this case, this is pretty simple. I mean, just see list one line data. This is just from an XML that you can get data, but in RDF that's not the case. You link. It's more like a graph. You link from different nodes, and you need to inferring those types is a difficult thing. Writing a type provider for that kind of a structure is much more complex than what we're looking at. So we need to find a way of
Maybe the question is, should you be, should it be a type provider to set of stored queries or something? Or,
that
you
could
know,
work.
Oh,
Well,
yeah, but I mean, at that point, just throw it in SQL database.
Well, okay, so what's like this? So the link data API, right, doesn't link data API have pre-cooked queries? I mean, that's how it works, isn't it? So the problem is that RDF is kind of this open world, and type providers need to be closed world.
Yes.
So how do we do closed worlds?
One way of doing that would be to load only certain data. I mean, like say certain nodes of the graph at every given point in time, and how many nodes do we want to? The threshold of the number of nodes that we want to load at any given point in time has to be decided, and that's the problem that we have in using this framework for RDF data. If it were just a simple vCard interface, probably this would work.
Well, the other thing too is when you're doing a lot of these things, it looks like you're selecting a number, like so on the previous example where we did the CSV, right?
Mhm.
You're selecting a certain number of instances and then using that to base all of your type inference, right?
Mhm.
But if I pick 10 arbitrary nodes in an RDF graph, they're not all guaranteed to be the same type,
Yes.
like in a table in a SQL database,
Yeah.
right? And so that's, I think, part of what you're trying to get at here.
Mhm.
I think another interesting thing is how do you deal with the semantics of it on top of that, right? So if I have an ontology which defines subproperties and subclasses and things like that, if your type provider wants to actually appear to be somewhat intelligent, it ought to be doing some of the inference underneath that. So if I state that a person has some particular attribute and that attribute is a subclass of some other attribute, then I should see that second attribute also appear in my drop-down list, right?
Yes.
And if it doesn't, then I'm like, well, it should have it, right? Because of the semantics of the system.
Yes.
So part of it is how do you deal with translating that maybe into something like Sparkle, but then also dealing with maybe some higher level inference that you may not necessarily be able to represent in a query language. You would have to restrict it to RDFS and OWL2QL or something like that.
So what you just said a few minutes ago was it would work for vCard. I think that's what you said.
The simplest RDF, because it's just one. If you could write just 4 or 10 nodes, and these nodes are not going to change all the time, it's going to work.
So what you're saying is if you've got a well-described vocabulary,
Yes.
where the vocabulary is acting as the interface,
Mhm.
so to speak. But that's true in a lot of situations. And in fact, that's true in a really big fat situation where you've got government data providers using the DCAT, say, for example, DCAT, W3C DCAT vocabulary. That's a consistent vocabulary across hundreds of thousands, or in
Correct.
our case with IOGDS, 1 million data sets. You've got a set of resources that have a consistent vocabulary being applied.
Okay.
Does that fit your model? So the question is, the problem is reflection over this infinite
Yes.
space,
Yes.
potentially infinite space. But if you eliminate that, if you say no, it's actually fixed. It's going to be this fixed vocabulary.
Yeah.
Is it also
A fixed vocabulary would make it easier to write a type provider. Not that it's simple, but it's much more easier to write a type provider for a fixed vocabulary than something which keeps
Well,
growing all the time.
So for a lot of applications, that makes sense. In a lot of contexts, you're writing against fixed vocabularies. I mean, instance data that's being built with a fixed vocabulary, a known vocabulary. You don't have to do discovery over it. You know, corporate situations or medical situations where they're not. Or am I misunderstanding? Somebody help me out here.
No,
my point is, if the problem is reflection over this infinite world where you don't know the boundaries is, then you just say, this is the part I care about. So your type
You
provider
just-
on the back end,
Yeah.
it only does a fixed vocabulary,
yes.
and you back that up however with the
Mhm.
queries that'll do that, or however you're supporting it, and that's all you're going to get back. It may not, when you get your thing in this end,
Yeah.
it's going to be restricted to the vocabulary terms that you know about, right? That the type provider knows about, but that's still going to. But that makes sense. You know, if you're a developer in some gray-suited, grumpy environment, that's a really good thing. I mean, because you're writing apps against data structures that a graph that you know about.
Yeah.
So maybe you should just have that as your base assumption, your starting assumption.
Well, so another challenge is how do you deal with data that is not homogeneous in the worldview you want to take, right? So I've seen, data sets where people have used DC Creator with a string, and then a different data set where people use DC Creator with URI. If you ever get these into the same data set, you were to try to do something like this, you infer that one has to be a type of something else, one has to be a type string. And if you're statically typing, do you just promote everything to object and then leave it to the developer and just throw your hands in the air? I mean, something like Pascal or OCaml or whatever will at least infer and then try to execute the right methods anyway.
But so that's a good point. But you have, I think you have to say, no, we have to be consistent on this. I mean, that's you can't. I would say that's misuse. But
it's certainly misuse in the context of the people publishing the data, but you can't just go around to everyone and say, well, publish your data correctly. You automate your application. Well, you can, but they don't have to listen, right? You ought to be able to make the application robust because you're trying to browse something that you can't control.
But you have a further challenge in this environment because it's strongly typed.
Right.
It's going to let the smoke out and I don't think you can coerce it.
So one way of doing it would probably be saying, okay, if you have data and there are different forms of data, like say, is there a finite number of ways in which people are going to represent this data, and can we put that back in the type provider mechanism? And would the type provider mechanism allow us to intelligently look at that? Just run, let's say, like a hash map and run through all these different data types that you have listed and compare them and say whether it's going to match or not. That's something which I've not tried. That was one of the initial thoughts that I had, but something which I've not yet tried, which is why I'm not.
Yeah, so use that example. I would use that example of DCAT as a working example, simply for selfish reasons, but also because the current W3C editor's draft has tries to be pretty prescriptive with its typing.
Okay.
So it's trying to force as much as any W3C recommendation can force anybody to do anything. To correct use of types.
Okay.
And it's intended for first for a government data provider environment. It's intended for that sort of thing. So what you anticipate is a bunch of governments around the world publishing data sets using that model for catalogs and for data sets in a consistent way with consistent typing. So, And you've got some people in this room who know something about DCAT, so. But I would encourage you to use that as a working model.
Yeah.
And kind of test us. You're an hour into it, so I would encourage you to wrap up.
Oh, I think, one other thing which I'd probably use Visual Studio, but you could do that in try F# also, is that, while you're building solutions to complex data sets, you could just compile only what you want to compile and see what the results are, and that makes it easier for programmers to compact the data and then look at where their errors are. So I could just run only these lines, or I could just it's
So this is because of the nature of functional programming.
because of the nature of how F# is, because of the inherent nature of a functional programming language. That's what it allows us. But it's still very useful, because if you're trying to build just new solutions for data sets, this is one way of doing it. And what we were talking about all along, this is where I just say what the Netflix catalog gives us, probably, yeah. So in this case, we're just looking at titles, but what you see is that the entire catalog that Netflix has, or Netflix is giving us, is being updated here. You could actually look in for data. So all these things that you wanted to know, DVDs, episodes, genres, or any of those, is just in that variable T for, let's say. And then you could just use it with any of the charting programs that F# gives you, and create interactive visualizations or work with data. So another simple example is about using it for something like Stack Overflow. Stack Overflow again is gives you an OData service. You could again see that what I'm trying to do here is, just print out those tags which contain F#. Just run this up. So these are tags which contain F# in your in Stack Exchange. This could be, if you had a Twitter F# data type provider, you could actually get in tweets, you could get in user IDs, you could work with them, and all that stuff. So this line here gives you the entire type, and once you get that, all you have to do is follow these links, so as to say. Do we have time till 9 o'clock, or was it only 1 hour into?
Usually these talks go to 8. So people are not conditioned to go that far. So I would. The
What
world
else
rec-
had you planned?
Yeah.
No,
The world record is 8:20.
Oh.
And we want to have like a little bit of time for conversation.
Right, yeah, so,
So nothing. I just wanted to show that since we are very much interested in visualizations, F# has an easy way of doing them, and probably okay. What I could do is just go to try F#.
Seems like you really have to click on the text to get to the words.
Yeah.
oh,
So you have data, and you need visualization tools to analyze the data and data analytics. F# provides you an easy way of doing data analytics instead of calling in another web service like Ajax. It provides you a simple Dojo chart. I think it also has a type provider for jQuery, so you could access all the jQuery libraries if you wanted to. You could just as usual, chart.line is your these are the different visualizations that are possible, and each one of them you really don't have to it's pretty much what Dojo chart would give you. Let's say if you had in some other library, probably let's say JQplot, for example. JQplot is a simple jQuery library which has decent enough plots, three-dimensional plots. So suppose you had a type provider for that, you could just access all of them easily here, get in the data from all these. Let's say you wanted to compare different movies of a director and see how many awards he's got. You could just probably put into feed the data here.
could I ask a couple different kinds of practical questions?
Mhm.
Okay. So what we're seeing, we're seeing some clever online interactive programming here, which is as advertised, try F#. Okay, and we're seeing also in the Visual Studio environment, which lets you do more powerful things, define, write your own. And when you and I talked a couple months ago, that's kind of what we anticipated. You're going to be really limited. How, other than the exercise of doing an RDF type provider, how is this useful? I mean, where would you put an F# program? Are you going to do back-end programming, and where would you use this?
Okay.
Is the microphone off? No, I mean it's a serious question. I learned. How would you? Where would this fit within, say, our stack? When you consider what Tether's World does, where would that fit in?
One advantage would be that suppose you wanted to just work with data and not learn SparkQuery. You just create a type provider and still access data. You really don't have to know how the underlying querying system works.
So that's an interesting value proposition. Do you think that really works?
Let's say
I'm not sure I believe it, but go ahead.
The inherent idea that what F# is trying to promote in this case, let's say if I still go back to a database in SQL because I see some analogies where it's much more easier to do. So let's say you really don't know how to query something, but you have this type provider for a database, and you don't know how to query. You can still get all those data that you wanted by just working with F#. And the same analogy works for different other kinds of data sets, wherein you don't have to learn a new language or a new way of querying the data set. which is inbuilt in the programming system itself.
But this is not equivalent to a query. I mean, you're still having to, it seems like you're accessing the data in a particular way,
Mm-hmm.
but then you're going to have to define the functions which filter that data, or pattern match in F#. So it sounds like you're replacing with functional programming on the F# side what you would do with your Sparkle query.
Yeah.
Oh, go ahead, go ahead.
No, one thing, coming back to your question, so ease of data access. So you start getting data, and then the next moment, 4 lines for you to start accessing the data, and then now all you got to do is to analyze the data and put it into new forms that you can work with. So it's a language more for the developer who's focused on analysis of data rather than the one who would be worried about how to represent the data.
Yeah. So I see the point that you're making. It's a very similar point when web service interfaces when WSDL first came up.
Mm-hmm.
Microsoft jumped right on it. Why? Because in Visual Studio you could plop the URL to a WSDL interface, and the developer was dialed right into that remote, that remote interface.
Mm-hmm.
And this has got a similar proposition, is if you've got particularly with OData, you've got a data interface,
Right.
and so the developer can follow her nose, basically. So I see that point, but I'm questioning a little bit how that applies in the RDF case. That I'm not questioning it in some of the examples you've given. I'm just contesting it. There may not be an answer, and you can tell me to shut up, and that's fine.
No, what I think is that functional programming offers us certain advantages, which probably an imperative programming language wouldn't give us. Now, by example,
He's drunk the Kool-Aid. He's drunk the FP Kool-Aid.
no, let's say, for example, an example would be if I had to work with natural language processing systems in an imperative language, a parser would go through line by line, and working through that is very cumbersome. But whereas I specify structures in a functional programming language, I specify rules, I could easily map them together.
Okay, so now you're talking, because now if you can use a type provider
Mm-hmm.
to play games with graphs and do mapping over graphs in the way that you're doing that with lists normally,
Yeah.
that becomes really interesting.
Mhm.
So if your type provider can get at graphs and subgraphs and that sort of thing, the structures within, then you don't think so?
Well, it's not that I don't think it's not. You can do it, but the question is what complexity is that going to be? Doing that is going to be NP complete just to get your subgraph.
That's the research problem.
Right, so you're right, and so this is where that open world comes
This could take, if you had like a graph with a million nodes, having this little pop-up come up could take you years, right? Potentially.
So you got
Big enough
it.
data set and a large enough complexity.
That's one of the challenges that we'll have to work around with, as in how many nodes do you want to show, or what are the important nodes that you want to show for a given data set.
So there is a class of problems that sort of deals with this whole graph programming thing. What's the guy's name who does he's one of the other, is it Marco?
Markham, yeah.
Yeah, that whole, how does that graph programming model fit into this whole thing, this follow? What's that language that?
Well, you're talking about Gremlin. The Gremlin was actually based on Ripple,
Yeah.
which is a semantic web scripting language, and that's it's a functional programming language for they can be embedded in linked data, It's,
Yeah.
it's for, doing path-based queries over that data. But what's the connection you're trying to make?
Well, I was trying to, that was just something that I was familiar with, but what I'm trying to think is if there's if there's an analogy here. I should just shut up because my brain's tired. But I think that there are.
It's not, neither of them are Sparkle-like languages for.
No, I'm
graph
not, I
cards.
wasn't trying to, what I was doing, I was stepping out of the Sparkle thing and saying, computing over graphs problem, and how do you make that tractable? And I don't know. So I think you should wrap it up. That way we don't have to worry about me talking anymore.
No, yeah. Part of the problem is just if it's just tables or rows and
Yeah.
columns, it's much more easier. But if it's a graph selecting subgraphs, which is the thing that Spark here does for you, that's what is going to be a complex problem.
Right. But I think that's
F#.
that's your problem description.
That's
I
my
mean,
problem.
yeah, exactly. And I think that finding a way and touching enough of the literature on graph problems and how do you make them tractable, probably.
So,
That would be the interesting problem.
yeah, one way to look at it is to get all the relevant nodes first. Like you have a node and the neighbors to be these nodes.
Yeah.
Which neighbors are the relevant neighbors that you want to show, and then a threshold on that number. And just like how Ajax came about loading some part of the data every now and then, so you keep maintaining a threshold, and as you go down, you send in different queries again and again to get back different nodes. That would be one way of doing it, but it has to be seen and how it's going to translate to F#.
Make it so. All right. So is that?
If that works, probably yeah, we could send it.
No. So one other question about try F#. Is there a way that it can be extended? I mean, do they have a way to propose new type providers that? I mean, we have connections. We could probably work that. But I'm just wondering if there's like an official route. I've developed these new type providers. Please, Microsoft, install them.
I think that's one thing which me and I were talking to Thomas the other day when he come here.
Mhm.
But from what my understanding of what he said is that it's not possible to do that right now. We'll have to get in through one of the community members to do that for us. It's not really. We just can't create our own type provider, put it on F# and start working on this
No.
environment here.
No, that's not what I meant. What I
Mhm.
meant is we create our own type provider and test it,
Mhm.
verify it, and then we contact them in some way and have them do that. That's what I'm wondering. If there's a
That's possible.
Yeah.
That's possible. And what they would do is probably just put it back onto this system, and then you could just
Right. 'Cause
just call in a DLL file like they just call them and start working with it.
Right.
No, I'm curious, like, it seems like you could take something like Clojure
Mhm.
and, there's tools like Clojure Script which will allow you to basically run Clojure programs as JavaScript in a browser, which, if you could do something similar, basically this just seems like an interface to me.
Yes.
That's all it is, right? I could write an F# program in Emacs, but it's not going to do the little fancy pop-up and tell me what's available. That's all, that's part of the IDE. It's not, to me, it doesn't seem like it's really part of the language, necessarily.
Type providers is the
Only in the sense that it happens at the
Mhm.
compile time thing,
Mhm.
right? But I should be able to take up any functional language and basically build a type provider functionality that just happens at runtime, which to me makes it seem like it's more robust because I'm not fixed to whatever the state of everything was at
Are you
compile.
getting strong typing in that case?
Strong.
Well, if you take a language like OCaml or Haskell, where it does a lot of the type inference for you on the fly, then you shouldn't need strong typing, right?
But that's a compiled language.
It's compiled.
That's kind of the strength of F#, is the fact that it's a compiled language. Easier to debug and all the other benefits of having it.
You can debug plenty of other languages. Why
Well,
do you
you
have
can
to be
debug it,
compiled
it's
so you
just
can be able to
that's what they
debug it?
claim, is that a compiled language is easier to debug.
Do you have like evidence to
I don't have
support
that.
So-
that?
so- so
I just
they
read
say-
it on their propaganda website.
Okay.
It's
I mean, their
on their
information,
website.
their information website.
Yeah.
Okay, on their information website, probably you could see that for yourself too. So this is what they say on an efficient execution on just-in-time compiler.
Right, but so Clojure is not strongly typed, but it compiles to JVM bytecode, which is strongly typed, which
Strong.
Java compiles.
Yes.
So, to say that you can't have the debug abilities without having strongly typed and compiled languages seems like a false claim to me.
I would say that they sort of claim that their only major claim is the type provider mechanism that they give you. It's not anything else. All the other things would probably be about how a new programming language comes about, some other improvements. The major improvement to F# 3.0 from 2.0 is the type provider mechanism. Whatever you said is still possible in all those languages as well. The only advantage in this case is about accessing data. Given you have different data sources, can you combine all of them together to make something new? And the time taken to do that is much more easier than this for somebody who wants to get at analyzing data very, very soon, rather than writing a complex system to get that data back.
All right. Yeah. So I mean, the type provider thing is a new feature. I'm just saying that it seems like you could just implement the same functionality in any existing functional programming language.
Yes, you can.
So, no, I'm not trying to make a strong claim there. I'm just trying to say, like, it seems like it should be pretty easy to do in any other language, and then you also can get the benefits of having, not having to statically compile things, and you can actually maybe even have some of these things I talked about earlier with having to load the CSV at compile time, right? If, let's say you add a new column, in the compile time case, you would have to recompile, right? But at the runtime case, if I'm never going to access that new column.
You're not going to access
right?
it.
So I should never get a runtime error potentially, because if I never was accessing it to start with, I might never access
Yes,
it.
you wouldn't get a
even though
runtime
it's
error.
added. But you wouldn't be able to stuff it into your statically compiled object, right? Unless you're doing something fancy underneath the hood where it's really just an object is just treated as like a dictionary or something like that.
The other claim that they would say is that this also gives you access to .NET libraries that you want to work with. So it's not just fully functional programming. You could access all the .NET libraries that you have with you already in the system, and you could just use them to do things that are easier in an imperative language, and then do things that are easier in a functional programming language, and build a better system basically.
Okay.
That wouldn't be possible in a just functional.
Well, that's what I'm
programming
saying.
language.
Like, so I again go to Clojure, which compiles on JVM, and therefore Clojure can use any Java library, including accessing something like Jetty or whatever. If you wanted to load a war and run it through there, you could do it. So.
Okay.
All right.
So
We all set? I know you want to keep talking, but
no, I mean.
just in short, what's the future in terms of your plans?
If-
Also connected to Microsoft or
Right.
any sponsor, but particularly Microsoft.
Um,
And actually, is the video still on?
we could
Why don't we,
turn it.
Wrap
yeah,
up and-
why don't we wrap up and then answer?
Yeah.
Okay, we just.
Well, let's thank Amar. Thank you very much. It's like functional programming oral exams here.